Here I have a cylinder, and if I want to find its volume, all I have to do is find the area of the base and multiply it by the height. So that would be pi r squared, area of the base, times the height. Okay, so now what I'm going to do is I'm going to just pour some gold or whatever around the outside and make a shell around it. Okay, and this shell still has the same height, h, but now its radius is different. So let's say the thickness of the shell is delta r. Okay, well, all we have to do to find the volume of the shell is using differentials, take the differential of both sides. So volume of the shell is approximately dV, okay, change in volume, which would be pi times the derivative of r squared, which would be 2r dr, or delta r, times h, because h isn't changing. So 2 pi r h delta r. Okay, so that's a formula we could use to approximate the volume of a shell if we knew the inner radius and then the thickness of the shell. So how much error are we making? All right, let me draw you a better one with a little bit more detail. All right, so this is still h, and then r is from the center to the inside circle, and then the thickness here is delta r. Okay, so let's find the actual volume. So what I'm going to do is I'm going to take my magic scissors here and I'm going to cut it open. Okay, because it has this in here. I'm going to cut it open and I'm going to unfold it. Let's do some color coding. Okay, here's the inside circle. So that's going to be this. And then, oops, let's make the outside circle blue. And it's bigger than the inside circle by delta R. And then the thickness right here, that would be this and this. And then the height. Okay, so what I have here is not exactly a box because, well, it's a box, but it's not a rectangular box because the side here is a trapezoid. So to find the volume of this, which is the volume of the shell, I have to do area of the base times the height. Okay, so here's the base I'm talking about right here. So it's a trapezoid. Oh, let's put some stuff on here. Well, if the radius of the inner circle is r, then the length of the inner circle is 2 pi r. And the radius of the outer circle is r plus delta r. So its length, 2 pi r plus delta r. And then this thickness right here, remember, is delta r. Okay, so the area of a trapezoid, half, big base, 2 pi r plus delta r, plus small base, times the height, which is delta r, height of the trapezoid, approximately. Yeah, sorry, I drew, this is delta r right here, all of these. Times the height of the box here, so h. So that simplifies into, okay, both these have a 2 pi, so let's pull that out. R plus delta r plus r, delta rh. So pi 2r plus delta r, delta rh. So that's the actual volume of the shell. So then the error we're making is our approximate volume minus the actual volume. Okay, the approximate volume, 2 pi RH delta R, pi RH delta R, minus the actual volume, pi 2R plus delta R, delta RH. Okay, they both have an H I can factor out, they both have a pi I can factor out, and they both have a delta R that I can factor out. So pi H delta R, and then what's left? 2R minus parenthesis 2R plus delta R. So pi H delta R minus delta R times minus delta R, or pi H delta R squared. I got minus for the answer because maybe I was supposed to subtract them the other way, and then that'll make it plus. Okay, so that's the error that we're making, which if delta R is small, this will be a very small error. Okay, there you go.